Okay, so we know now how to put in our isobars, and now the question is, how would I put in my fronts? And so the first thing we do is we locate our area of low pressure, and as we can see over here, our lowest area of pressure is 1,000, so our area of low pressure would come up here in our low. And then fronts always start out from our area of low pressure, and then they extend from that area out as far as the leading edge of the air mass is. Around an area of low pressure, our lines or our air is moving in a counterclockwise manner. So our air is moving this direction around our area of low pressure. And that tells us how the symbols on the front lines are actually going to be facing, because they'll face in the direction that the air is blowing. Because the symbols on the outside, these symbols here on our front line, tell us which direction the front is moving. So in this case, we would start our front from our area of low pressure, and we would have it extending outwards from our area of low pressure with our front symbols moving, showing that counterclockwise directional flow. Oops, that didn't stay together. Our worm front will still be attached to our area of low pressure because that's where all of our fronts originate from. We have to have that area of low pressure in order to have fronts, because the area of low pressure is where we have warm air that is rising, and that's what allows clouds to form. So once again, we would have our front that's attached to our area of low pressure. Our air is still moving in that counterclockwise motion, and so we would have our front symbols that are facing in the direction that the air is moving. Now when we look at the temperature-wise, and when we look behind our front and in front of our front, the fronts themselves are named because of the mass of air that's behind them. So a cold front here is named for the big cold mass of air that's behind it. This is the leading edge of this giant mass of air. So behind our cold front, it's going to be colder than the air that's in front of our warm front. And with our warm front, it's named for the big mass of warm air that's behind it. So it's going to be warmer behind our front, and then it'll be colder in front of our front. If we're looking at the cold front, when the cold front comes into an area, the front line for a cold front, it looks very different from that of a warm front. So a cold front, the front line looks kind of like this, because behind that front line, we have this big mass of cold air that's coming in. And it's pushing its way into an area that has warmer air. Now, one of the things that we will be talking about a little bit later on and doing an activity a little bit later on is about what happens for clouds to form and when we get into those areas. But remembering back to the lessons that we already talked about, there's three things that are required for precipitation to form. We need to have a solid surface, we need to have saturated air, and we need to cool it down to its dew point. And so when we have this big mass of cold air that comes in, we remember that warm air can hold a lot more moisture than cold air can. So as the cold front comes in, it's going to displace this warmer air. It's going to push it up, right? Because warmer air is less dense than the cold air. So as it pushes it upwards in here, it's going to cool it down to its dew point. The air is going to become colder, so it's going to reach its saturation point. And so that's why we get a lot of storms that happen right along this leading edge. So we get a lot of clouds that form, and we get rain that forms right along this leading edge of the cold front, and then also right behind the cold front. When a warm front comes into an area, the front line looks a little bit different because the warm air is less dense, and so it's going to want to slide over the top of the cold air anyhow. So when a warm front comes in, this is our warmer air mass, and this is our cooler air mass or cold air mass. And so as the warm air comes in, it kind of slides over the top of the cold air, and so we get clouds that form this way. You tend not to get a lot of thunderstorm activity when the warm front comes in because the air is not getting pushed up really rapidly. It's kind of sliding in slowly, and so we get stratus clouds, or we get cumulus clouds, but we don't get a lot of those cumulonimbus like what we see during our monsoon time.